the importance of good latency or network performance for services like virtual reality gaming.
Right.
We believe that online gaming, as it's done today, which is largely on the PC or on the laptop, is going to move towards virtual reality in the future with 5G going forward as well. So we believe that almost 1 in 3 users, online users, will be doing VR by 2020. So it's a substantial number, it's going to mainstream, but the key is to understand what is the expectation on the quality or the network performance of virtual reality.
And I guess we've seen it, there are a whole bunch of transitions now with devices. We're seeing phones now come out with chips dedicated to neural network processing. They've got additional GPU and in some cases tensor capability built into the phone now. So you've almost got like a supercomputer in your hand. We had a powerful computer, now a supercomputer. We're seeing the transition to distributed cloud with the workloads going to the device at the edge of the network where the data is. So with 5G being an emerging technology, now we've got that low latency, synchronous bidirectional ride. So this means that a whole new paradigm of gaming and services are available in VR because you don't have to send it all back to a data center and then send it back, which kind of made it impossible and you'd lose track, right? Give us some context on how you kind of how you went about building this demo and what's involved in the stack.
Yeah, okay, so as Jasmeet mentioned, future augmented reality application, virtual reality application will demand more capacity, more jitter, and lower latency. But now we are doing we are using groundbreaking techniques such as neuroscience to understand how latency and other network problems affect our brain reactions during the gameplay. Okay?
Oh, I like that.
Yeah.
So you've taken two components. So when are you talking about machine learning and artificial intelligence that's looking at the network and what's moving in the network? So it's only moving what it needs to when it needs to?
Exactly.
Yeah.
It tells us what the network should be like.
Right.
Exactly.
So it's more than just a smart network, it's an intelligent network, right? So machine learning, machine intelligence. Now, tell me about the second bit just briefly. So you were talking about the interaction with the brain and how the brain behaves. Give us a bit of insight on what that's all about.
With this neurological headset, developed by neurons, we can translate your cognitive responses into different KPIs to understand what was your performance during the game.
Right.
If you have been stressed, the cognitive load, the information that you have received during the game.
Because I mean, we've seen an interesting transition from sort of keyboard games and shoot 'em ups to fully immersive devices, I guess. When we go full immersion with augmented reality to virtual reality, there are going to be some very big impacts. I mean, we've seen things like Facebook and social media where they're gamifying and they've got psych degrees and game PhDs working on how to trick you to do things. I imagine the full immersion is going to have some pretty deep impacts on the psyche, the behavior, and the happy and sad experience. Tell us your part about in this whole thing and give us some insight into kind of what you've done about working with the data and the benefits of the low latency.
So basically what we saw when we did the test with neurons and with two guys here, we saw that we needed a low latency. Because if we didn't have the low latency, people actually got stressed out.
Right.
They got dizzy. We actually had to hold some people so they didn't fall off the floor.
Off the platforms.
So it's really important for the brain to have a low latency so it can simulate like it's virtual reality, right?
Yeah.
So we need to make it look a lot like real life.
Yeah.
And if we have latencies in there, we don't have latencies in real life, right? So it messes with the brain actually.
Yeah.
So that's the important part.
I remember doing some early stuff with VR with the Amiga 500 and the Amiga 1000 in the early days. We had that very same problem. That we would have to build delays into the code so that before we displayed what was going to happen to you, we had to cache all the data, the graphics, and render, and then push another layer because we'd have people tripping up on flat floors.
Yeah, exactly.
For that reason, right? So you're talking about now you've got the network capability with 5G. You've got the low latency of like sub 5 milliseconds or something. You've got intelligent networks. You've got all of the, I guess, the shrinkery of thinking about the tricking of whatever. Tell us about what we're actually going to see now.
Yep. Okay. So I think what you're going to see now is that we will immerse you in a gaming session in virtual reality.
I can't wait.
Yeah. And this is going to be a multiplayer first-person shooting game called Pavlov VR.
Oh my God.
And the reason why we have picked this is because most of the first-person shooting games are very latency sensitive.
Right.
And you will be experiencing this but we will take you through different levels of network performance and latencies, and then exactly measure how your brain responds to some of this.
Ooh, I like that.
And eventually we will come back and talk about the results as well.
So you're kind of layering you're giving me sort of high latency to see what the response is, short latency, and then down to near real time, and mapping that, and I guess collecting data and then doing, I guess. Now, one quick question. When you built this whole model, how did you go about building the training data set? And I guess it's essentially trained learning as far as the assisted learning or machine learning platform. You didn't just unsupervised learning this whole process, did you?
So I think what we are doing here is essentially research data that we have collected from a sample of consumers, online gamers. Some of them are intense gamers and so forth. And the underlying platform out here is the research data. And the way, when you go through the demo is actually picking up the data from the research. So it's looking for patterns, looking for your results into the database, and then suggesting and predicting what your gameplay eventually would look like, which is whether you're going to lose the game or whether you're going to win the game based on the network performance and your brain scores.